Hello students, today we will be doing a video on the concept of torque. Okay, the heading, it's a derivation and the heading is torque on a dipole. Okay, uh, torque on a dipole in uniform electric field. Okay, in uniform electric field. Okay, so torque on a dipole in uniform electric field. Now torque, in class 11 you had been exposed to the concept of the torque. What is torque? Torque is the rotation, right? Torque is a rotation due to a force, right? Rotation due to what? Due to a force. All right. Okay. When you open the water tap, okay, with your hands you apply the force, right? But that force will will cause the rotation of the water tap, and finally the water comes out, or the water goes down, right? So whenever a force produces the rotational action, then the concept of the torque comes there. Okay, like tightening a bottle, tightening the screw, or losing the screw, all these things. Okay, now suppose, let me come to the case, uniform electric field represented by the field lines. Okay, and here let's say a dipole is kept. Okay, a dipole is there. Let's say this is plus q and this is minus q. Okay, a dipole. And let's say this dipole is an incline at an angle of theta. All right, now this is the direction of the electric field. Then on q, what force is acting? On q, the force which is acting is what? QE. And what is the direction of the force? This is the direction of the force, right? Isn't it? Right? And on QE, what is the force acting? The force is the same, but what is the direction of the force? The direction of the force is like this, right? So you have seen, see, whenever we are talking about the direction, we do not keep the sign in the formula. The plus and minus will be clear from its direction itself. Okay, so because the field lines always goes from positive to negative, so in this side we can imagine there is the negative will get attracted to the positive, so the force will be acting this way, right? And on the positive, the force will be acting this way. Now what is the net force? Can anyone say on the dipole what is the F net? F net, what is that? One force is across here, another force is across here, right? So if I take this direction as positive, this is QE, and another is what? It will be minus QE. So what is the net force? The net force will be 0, right or not? Okay, because one force is acting across the positive and across another force is acting. So if the net force is 0, okay, now force is from the newtons, this is mass into acceleration, this is 0. The mass of the charges cannot be 0, so as mass cannot be 0, so what is this? Acceleration have to be 0. That means what? There is no linear acceleration, right? There will be no linear acceleration, so it will not going to move any linear. So translatory, we call this word translatory. It is a translatory equilibrium, right? So in class 11 you have learned equilibrium. Equilibrium means what? Equilibrium means the force is 0, right? So it is not going to move across any of the linear directions. But what about the rotational? Is it in rotational equilibrium? Now, the question comes, is it in rotational equilibrium? Okay, we need to check it. Okay, all right, is it in rotational equilibrium? Now you see, one force is dragging the positive across here and another across here. One is dragging across here, another is dragging across here. So what it is, isn't it? All right, so there comes rotation, right? So when there is rotation, there cannot be rotational equilibrium. All right, so when there comes the rotation, then what concept we have to study? We need to study the concept of torque. Because what is torque? Torque is rotation. What? Due to a force. So the rotation due to a force is basically the study of torque. All right, now in again class 11, this torque is denoted by a symbol of tau. Okay, just like a T, but the tail of the T is turned a bit. All right, now in class 11 we have studied the definition of the torque. The torque is the the formula for the torque is either of force, all right, either of force into the perpendicular distance between the force. Okay, perpendicular distance between the force. All right, so this is the definition of the force. Torque equal to either of force into perpendicular distance between the force. Now perpendicular distance between the force, now you see one of the force is across here, right, and another force is across here, right? So what is the perpendicular distance? This is the perpendicular distance, right or not? Now in this case, what is the perpendicular distance? The perpendicular distance is this, right or not? So this is the perpendicular distance, right? Now shall I name it? Let me name it as A, let me name it as B, and let me name it as C. All right, so okay, in your note copy I may have used the other notations, that will be up to you students. Okay, either of the force and the perpendicular distance. Now either of force, what is the either of force? The magnitude of either force is QE, and what is the perpendicular distance in this case? The perpendicular distance in this case is AB, right? Now can I represent AB in terms of something? This is dipole, right? What is the total length of the dipole? Total length of the dipole is 2L, right? Now this is perpendicular, right? This is 90 degree. So this is hypotenuse. This angle is also, if this angle is theta, this angle is also theta, right? Isn't it? Now if I take this right angle triangle, okay, right angle triangle ABC, then what it is? Sine of theta. Sine theta is equal to what? Opposite by hypotenuse, right? Now hypotenuse AC is 2L, then it is AC sine of theta. This equal to AB, okay, this equal to AB, so this is what? 2L sine of theta is equal to AB, right? So in place of AB, what can I write? This is QE into 2L sine of theta, right? Then this is 2LQ E sine of theta. 2LQ, this is what? Dipole moment, right or not? So sorry, implies torque, right? This implies torque equal to, this is what? Dipole moment, P sine theta, right? Isn't it? So basically this is the expression of the torque acting on a dipole in a magnetic field. That means if the dipole is inclined at theta angle, the torque acting is given by P is sine theta. You need to remember this one. Alright. Now in terms of cross product also I can write it. Torque is equal to what? P cross E. Alright, because AB sine theta, A cross B, right? So this way we can write it down. Okay, so students, you need to remember this one. You need to learn this derivation. Thank you.